Advanced Surface.
The Advanced Surface Utilities palette in Platinum provides several extra tools for modifying surface that includes Match Surface, Rebuild Surface, Insert Knot, and Elevate Surface. Let's demonstrate the Match Surface tool. First, we'll create a cover surface on the top that we will match with the bottom surface. Select our tool, select the type of continuity that you want, select the edge of the surface you want to modify, and finally the surface that you want to match to. In the first case, we modified the bottom surface. Let's do that again, and let's modify the top surface to the bottom surface. The match surface supports matching position, tangency, and curvature. Let's now look at the rebuild surface. The rebuild surface reconstructs an approximating surface to the reference surface. This tool works best with 3 or 4-sided surfaces. If you are concerned about surface isolines going to an infinite point, you can use this tool to change the parametric distribution. Next, we'll look at the Insert Knot tool. This tool introduces a new row or column of control points to a surface. By inserting a knot into a surface, you gain more control points to manipulate for finer control over a shape. To show control points, select the surface and then select Edit Show Points. Lastly, let's look at the Elevate Surface tool. The Elevate Surface tool increases the polynomial degree of the underlying surface from 2, 3, 4, or 5th degree. In this example, we have a sphere. We've converted it into a spline surface. If we look in the inspector, we see that it is a 2x2 rational surface. If we select it and elevate it, you'll see additional control points that we now get for the surface. And as we did in the previous example, you can select these control points to do further modifications to the surface. In this example, we'll take a group of control points, move them up, and we'll create our sphere into a capsule.
Blend tool.
The Blend tool has the ability to assign a version to use for fielding and blending calculations. Blending uses the ACES modeling kernel, which is constantly evolving their algorithms. In some specific cases, older algorithms may provide better results. In order for the designer to have more control, there's now an option to use the current or version 10 blending algorithms. In this example, we have a complex fillet that requires version 10. Let's show the steps how to change the blend version. First, select the constant radius blend tool. Then, in the prompt area, select the options button, and from the pull-down menu, select version 10. Now go ahead and set your blend radius. We'll set ours to 1, and select the edge that you want to blend. And then if you want to explore different radius values, just go to the data entry window while it's still selected and enter your values. In general, use the default current version. If for any reason that fails to provide the desirable results, try the version 10.
Copilot overview.
In this video, we provide an introduction to Copilot, an AI CAD assistant integrated directly. Copilot can help you with the following tasks. It can query into a large data set of documentation and find relative context. It can talk directly to your CAD data by extracting mathematical properties and attributes. And it can help identify anomalies and issues with your CAD data. We're going to go ahead and demonstrate some of these features today. Now, let's begin with showing a traditional way a designer would access documentation. So let's go ahead and bring up our user guide, and we're going to type in some keywords, and we'll do some keyword searching. We're going to search for solid from profiles. And then we'll click on it. Basically the keyword searching, you put your keywords in, it gives you a whole list of stuff. You examine the list and then you pick the content and from the list. Another example, let's go to our YouTube channel and let's do another keyword search. We'll type in solid modeling and it'll find a list that we can then examine and pick and click what we want. Now let's see what we can do with an AI assistant. An AI assistant, we can ask it to tell us what tools are available for solid modeling and to provide any videos related to the tool. So in one click, we're going to go ahead and we're going to have it analyze all of our documentation, get the proper context to answer my screen, and provide any videos related to my question. Okay, so now it's found, what tools we have available in ViaCAD. We have solid primitives, profiles, booleans, features from solid utilities, local face, or direct edit modeling. And it's come up with a couple of videos. We can go ahead and click the videos. Here's one that we have regarding how you can do threads in ViaCAD, or here's a whole playlist associated with solid modeling that you can get. This is called RAG, Retrieval Augmented Generation, and it's a great first step for AI in CAD. Now, what's great about RAG is it can take a query or a concept and it can create a response that may not be obvious or what you could find with a simple word search approach. So I think that's very exciting for any experienced designer to learn and interact with a set of documentation that we didn't have before. Now, as one more example, let's ask Copilot to tell me something interesting about ViaCAD. So Copilot has reviewed the context and it found the section on parent-child associativity as interesting. Now, if you use keyword searching through the user guide, nowhere are the words interesting and associativity mentioned together. Copilot has come up with something unique and different that I couldn't have found using traditional methods. This idea got me so excited that I wondered what would happen if I threw at the AI CAD data instead of user guides. What would it find interesting about a bunch of mathematical properties and attributes? I mean, I have at my disposal a very precise modeling kernel using Dassault ACES that can calculate and provide all kinds of properties ranging from derivatives, mass properties, continuities, lengths, areas, volumes. Well, it surprised me, leading to the next set of demonstrations. Now, let's see how Copilot works directly on my CAD data with my file. We're going to use the wrench file I used some years ago to demonstrate 3D printing of a single STL file with movable parts. First, let's get a summary of my file by typing in the following. Summarize the entities in my file for interesting properties. Okay, so it has examined my file and it has extracted out some metadata from our file properties attributes where I can get some comments about the file. I can actually, my metadata includes the actual video of the 3D printing. I can click on it and it'll play my video for me. It can also, it's reviewing all the entities I have in my part. I have a screw, it has some mass properties, density, material name, I have a handle, and I have a grip. And then there's some overall file properties. So that's interesting. It's just a really quick summary of what I have in my file. Let's go do something else now. I'm going to have it examine my file in detail for 3D printing to explain whether it passed or failed or if there are any warnings associated with any of my files. So let's go ahead and put in our question and hit apply. Okay, we received our results back from our question regarding 3D printing. And we can see that it provides us with a summary of each of the parts. There's 3 parts. And it tells us that the test that it passed includes it's a valid volume. There's no issues with the facets such as being duplicated or collapsed. It's closed and watertight. There's no non-manifold edges. It's a single component. And its normals are consistent with orientation. Same thing for the handle and likewise for the grip. So this shows that it will pass the initial test for 3D printing. Alright, next up I want to ask it why I can't blend my part with a 0.6 inch blend. So let's go ahead and put it into the AI query and select my object and click apply. Okay, and it returns back and it tells us that it can't blend because of the tight curvature that exists in the file. And in fact, the minimum radius of curvature is 0.46, implying that radial blends higher than that are going to fail. Now, one thing I want to do next is I ask it where the minimum radius of curvature occurs. So let's ask it that so I can get a location on my model to further understand the situation. Okay, so I'm just asking it where the minimum radius of curvature is for the selected entity. Okay, and it is telling us it is at this location, 9.2 minus 0.299.4. And if I create a little sphere at that point, that is this location right here. And you can see that that is a really tight turn in the model that is preventing larger blends. Lastly, just a few words about the state of AI as we look at some of the question answers we've used to test the Copilot so far. First, everything is rapidly changing. The underlying technology that we are using, consisting of machine learning libraries, large language models, system prompts, user prompts, embeddings, assistants, and agents, are rapidly changing and evolving. But some large issues remain that include 1. The need to improve accuracy. The response accuracy needs to get consistently better, especially in engineering where precision and accuracy matter. Much of this is dependent on LLM models' continued improvement. AI is an incredible assistant for an inexperienced engineer who has the ability to double-check the AI. However, for an inexperienced engineer, the results could be disastrous. Large language models need to follow system and user instructions better. I frequently see the large language model deviate from my instructions with what I call lazy responses. And finally, performance needs to improve. Currently, responses can take 15 plus seconds. For a designer exploring ideas, the AI needs to keep up without breaking up the thought process. And some final thoughts about my experiences so far. The integration of AI with CAD technology represents the most thrilling advancement in the field that I have encountered in decades. And we still need to explore text to CAD using scripting or image reconstruction during Sora. Reflecting on my journey since the early 80s, when I had the privilege of being part of a pioneering team at Lockheed that facilitated the transition of engineers from drafting boards to CAD, I cannot help but get excited at the impact this combination will have on engineering productivity. As a longtime CAD developer, it's exciting to be part of this next transformative stage in CAD. Thanks for watching. Stay tuned for more.
Cover from Point tool.
In this video, we demonstrate the Cover from Points tool. Cover from Points creates a surface from a collection of points representing the boundary of a surface. This will create a planar or non-planar surface depending on your point locations. The Cover from Points tool is an option that can be used to help fill or repair gaps in surface models. Let's demonstrate by filling the hole in our diamond gem model. But first, let's use Copilot to examine the topology, which confirms it's a single surface consisting of 72 faces and 8 open edges. We will fill those open edges with the Cover from Points tool. To begin, pick the Surface Modeling Tool palette and select the cover. Then select the Cover from Points sub-option. View the model where you can pick the 8 vertices. Now select each vertex and end with a right click. Next, let's join our cover surface with the rest of the model to confirm there are no more leaks. We'll use the Join Surface tool from the Surface Utilities and pick the 2 surfaces. Note the response indicates that this now forms a watertight solid. And lastly, let's confirm with Copilot the repair with the Cover from Points surface and joining created a valid part with a volume. And we can see that this part now has no open edges and correctly provides a volume.
custom texture.
In this video, we show how to create and use custom textures for rendering. First, let's go ahead and create a texture that we'd like to add to our picnic table design bench. We're going to use Copilot's text-to-image capability. To do so, we're going to go to Copilot and the predefined prompts, which has a section just for text-to-image examples. One of them is an example pine texture. Let's use that to start with. And we'll modify it. We're going to remove the prominent description of the grain, and we're also going to change it to be, instead of uneven, we'll change it to be even. All right, once you get your prompt all set up, go ahead and hit apply. Now, if you look in the Copilot documentation, you'll find some examples on how to improve your prompts. Okay, it's come up with a couple examples for us. Let's go ahead and copy the image into our paste buffer, and then I'm going to go over to preview, and I'm going to do a new from clipboard. Alright, this is going to put both those textures into preview, and what I'm going to do next is I'm going to crop one of these. And so I'll go to do edit, select all, and I like the top one, so I'm going to pick this top section to crop out like so, and then I'll just select crop. And oh, I got a little white band up there. Let's do that again, and let's pull it down a little bit more. And now hit crop, and then go to save, and we'll call this light oak. We'll call light oak 5. And now let's go back over to our model. And what we want to do is show how we get that into TurboCAD Mac. So we're going to go to our photo render library. We're going to pick the photo render settings, and we'll go to textures. We're going to use base color, and we're going to use user, and we're going to go from file. And then we will select light oak 5 and click open. And then what we'll do is we're going to select everything in my file, and now that light oak that we just created is now stored in your user custom folder, where we can go and we can pick it. Here it is, light oak 5, and I'm going to hit apply, and this will now get assigned to the objects in my file. Next, what I'd like to do is show you a couple of tips related to using custom textures in your model. Let's zoom up on this bench, and let me show you some parameters that we have available once we have a texture associated with a model. Let's go ahead and select our bench top, and then using the photo render settings dialog box, let's select textures, and then we can see the current texture, light oak 5, that's been assigned to it. And now we have 4 different options over here that we can tweak our settings with our texture, including gain, which is an intensity associated with your texture, a rotation is whether you want it horizontal, vertical, for example, or you want to change the scale along the U or the V axis of the texture. One other way you can control some of the display of your textures is to go to your post effects. Post effects has the ability to set a gamma associated with your model. This will correct bright, dark, contrasting regions in your image. And you can also turn on tone mapping, which will kind of balance the light out throughout your image. One other tip regarding custom textures is now when you import a SketchUp file, all of your SketchUp textures are automatically placed in your user custom folder. And don't forget, you can use Copilot to examine your file for what textures are used and where those files are located. Simply ask it to list all the textures and scene data in your file. And here it lists each of the entities with its texture, the path and the name, and then of course there's also your scene data, what you're using for your background image and what you're using for your HDRI.
Edge treatments.
Edge treatments add or remove material based on user-supplied parameters and are associated with the edge of a part. The edge treatment tools are located at the end of the feature tool palette. There are 3 edge treatments Platinum supports, which are lip, groove, and flange. Let's look at the groove tool. The groove tool removes material below the selected face on the selected edge using a supplied height, width, and angle. To use the groove tool, select the top face for the groove, the edge to remove the material, and specify the parameters in the data entry window. Next, let's look at the lip tool, which adds material above the selected face on the selected edge using height, width, angle values. Use the data entry window to explore different values for the height and the width of your lip. Let's also create a groove and show how the lip and the groove features can be used together. We'll create a quick groove on the part to the left, and then we'll go ahead and use our assembly tool to mate and align the lip and the groove features together. And now let's look at the flange tool, final tool in the edge treatment palette, where we select the face and the edge where we want a flange added to an existing part. And you have the offset and the thickness values that you can modify associated with this feature.
Fastener library.
The symbol library was updated to support a fastener library. To access the fastener library, look at TurboCAD Explorer tool palette, select symbols, and then go down to fasteners, and you'll see there's nuts, bolts, and washers. Let's go ahead and demonstrate how you would add a bolt to a drawing. I'm going to open up the tree for the bolt, and then we'll go ahead and select one of the sets. Find the one that you want. Now you can right click up into the top and you can make your previews bigger, which will allow you to see the names a little bit better. Let's go to large previews, and then simply click on a symbol and drag and drop it into your drawing. Now if you have any need to find out better explanations of the naming convention, just go ahead and pick the name of the part and go over to Copilot and ask it to tell you about that naming convention. In this case, it'll tell you that it's the bolt diameter is 0.75. It also tells you the number of threads per inch, and it's a Unified National Fine thread. One more thing that's kind of useful tip when working with the fastener library is how to insert them into a part. And to do that, we're going to pull out the advanced transform palette, and we will pick the assembly tool palette, and then from there we will do insert face. Now what it wants you to do is to pick the face that you want to align, and then what you want to align it with, and then the mating face of the bolt, and then the mating face of the part. And then here you can see it placed our fastener inside of our part using the insert face tool.
How to register Copilot.
In this video, we demonstrate how to register Copilot. Copilot comes in 3 flavors. Trial, which includes professional access for 2 weeks, Copilot Help, which allows you to talk to our documentation, and Copilot Professional, which allows you to talk to documentation, CAD Data, Image, and General AI. Let's go ahead and ask a question for Copilot. Let's ask, tell about spline tools. And we'll type in our question, hit apply, and we'll see that Copilot's not enabled for this product, and it tells us how to go about to register it. And we need to go to the Help, Copilot Registration. So let's do that. Let's go to Help, Copilot Registration, and we'll get a dialog box where we can enter our information. So I'm going to type in my name, my email address, organization, and you'll get a key. So let's go ahead and activate it. And now let's just go ahead and re-enter our question about tell me about splines. And here you can see we get a response. Now you can also tell you're activated by going over to the Preferences, Registration tab, and you'll see here we have our Copilot activation key stored. Now if you ever need to disable Copilot, for example, if you have Copilot Help and you want to upgrade to Copilot Professional, what you will do is come into Copilot, type in clear, and then hit apply. Are you sure you want to override it? Yes, we do. And now we see we have turned it off.
Introduction to Copilot.
Welcome to TurboCAD Copilot. Copilot utilizes a suite of tools to elevate your design workflow by allowing you to talk directly with a variety of resources unique to TurboCAD Mac. Information resources include user guides, frequently asked questions, blogs, your CAD data, or the general design knowledge pool. In this video, we'll explore Copilot's user interface and options available for asking questions. First, let's look how to access Copilot. Copilot is accessed through the menu bar, Tools, TurboCAD Explorer. Within TurboCAD Explorer, select the Copilot tab. Within Copilot, you now have options to use some predefined or curated questions using HTML formatted data, as well as example prompts that access the documentation, CAD data, or the general knowledge base. Let's go ahead and ask it what kind of 3D print tools are available with TurboCAD Mac. And we're going to go to some example questions, and we'll put the question in and just hit apply. Okay, it's found from our user guide, it's found a variety of tools. And in fact, if we want to go directly to the user guide from here, we can click on a link that it provides, go to the search tool and type in 3D printing and access the documentation as well. Next, what we want to do is provide a question related to the file. And I'll go back over to some of my curated questions, and let's ask it to examine my file for 3D printing. Okay, it's returned, and it's provided a set of results from a series of tests. And it sees that we're within our volume. There's no duplicated facets, collapsed facets. It is a watertight body. There's no manifold edges, no warnings, consistency with the normals. And it gives some individual part analysis and more or less says that this part is fit for printing. Now let's do another test. Let's just ask it to tell me something interesting and engaging about my file. Now this is an example where it just examines some of the file properties, some of the mathematical characteristics of the geometry as well as attributes, and it sends it all to the AI to see what it can come up with as interesting. Okay, it's returned with some observations associated with my file. It noted from my file properties the name of the file that was created by myself, and that it's a file that serves as a 3D printing example. In this particular example, I assigned it a steel material type. It picks that up. It also finds my bounding box and size of the part. And it notes that this is part of a video that I made showing how to do 3D printing. And it puts a link to that as part of the file properties. And then it finds some interesting geometric data associated with the 3 parts regarding the names, the types of objects that they are, the volume, centroid, and some principal moments of inertia. Lastly, let's go ahead and have it do something outside of the knowledge of our documentation and outside the knowledge of our CAD file data, and ask it some questions about 3D printing. I want to ask it for some suggestions on materials for 3D printing, as well as provide some cost estimates. Okay, so it's returned back with a list of potential material types and a possible cost estimate for each of these, along with the strengths and the weaknesses for each of these choices. And then it also provides some notes for us. Now, one more thing you can do is you can save your data, and I'm going to go ahead and save this out so that I can recall it, and it'll bring it up into a browser, or you could just bring it back into Microsoft Word. And if you want to get more information about Copilot, go to the Copilot Frequently Asked Question drop-down, and it'll give you the latest information about Copilot, its uses, some example prompts, keywords, and kind of how it works for some of the data extraction, how you can improve, does it support languages, and such. And to conclude, let's show some example questions and answers from Copilot.
Layer Set tool.
Hi everyone, welcome to our video on mastering the Layer Set tool. This powerful new feature is designed to streamline your workflow by allowing you to save and restore groups of layers, complete with specific view orientations and zoom factors. Layer sets are very versatile, serving multiple purposes to enhance your design workflows. Whether you're swiftly navigating through different work setups or showcasing saved views for a presentation, layer sets are your go-to solution. In today's video, we'll dive into the practical application of layer sets within our race card project. You'll learn how to create a range of views, save them for future reference, and seamlessly switch between them with ease. Let's begin by creating a layer set of our race car, bounding box, and dimensions. I'm simply going to turn off my cameras so that I get just my race car, and let's zoom up, and that looks good. I'm going to go to layer sets. Layer sets are in the Concept Explorer, located under Tools, Concept Explorer, and it's on the lower left hand side of the screen. We're going to click Create Layer Set, and we're going to give it a name. We'll say Dimensions Bounding Box, and we'll click OK, and that creates it. Now let's go ahead and create another one, and this will be without our bounding box and layer dimensions. So I'm going to turn off our dimension And I'm going to turn off the bounding box, and let's change the orientation a little bit and zoom up. And we'll create another layer set, and this time we'll call it race car ISO only. Okay, now I also have in my drawing I have a variety of rendered images that I want to quickly show. And what I will do there is I'm going to start with just the front view. And I'm going to isolate that layer, and I'm going to zoom up, and I'll go to my layer set, and I'll say create layer set, and we'll do race car front view rendered. And let's do our side view, same thing with our side view. Let's zoom up and create another layer set, and this will be race car side view rendered. Okay, we've created our layer sets. We can review our layer sets by clicking into our menu, and we can see I created 5 of them. And now let's switch between them. Let's go to our dimension with the ISO bounding box, and now let's go to the race car ISO only, and let's do the rendered front view and rendered side view. And for our next example, I have a 2D drawing, and I want to show you that layer sets are equally as valuable if you're just using 2D drawings. This is a large AutoCAD drawing with a collection of draw views as well as model set data. I've already created some layer sets, and I'm just going to recall these for you. The first one we're going to do is the model view, which we're seeing right now. And then let's go ahead and recall a rear view data. And lastly, an upper frame assembly. So you can see it quickly jumps between models and sheet views.
Platinum blending.
Platinum adds 3 more advanced blending options that include 3-face blends, thumb weights, and curvature continuous blends. Let's go ahead and demonstrate the 3-face blend. A 3-face blend will take as input 3 neighboring faces and create a variable radius blend that consumes the middle face. The radius is determined by the geometry positions of the 3 faces. Next, let's do a thumb weight. The thumb weight creates a smooth transition along the edge that includes the ability to specify a bulge factor. The thumb weight blend does not have an arc for the cross section, but has a smooth spline. Increasing the bulge factor pushes the blend along the tangent vector. And likewise, decreasing the bulge factor lowers the influence, resulting in more material being included in the blend. And finally, let's look at the curvature continuous blend. The curvature continuous blend creates a smooth G2 blend along an edge or sequences of edges. Use the data entry window to change the radius value.
Rendering tools.
Hi everybody. In this video we're going to demonstrate how you can use the new rendering tools in version 14 to produce photorealistic drawings. Included in this presentation, I'm going to provide the sample files used to create this such that you can recreate it yourself. For example, let's go ahead and show the folder that I'm going to provide and explain what's in it. So the folder is going to have 6 files. It's going to show example images of what you can create with this tutorial. This is an example where we're showing the camera towards the window. We're also going to change the camera in the HDRI to point towards the wall. We're going to provide a start file from which you can do the same steps that I'm doing in this video, or you can just pick up the final file. And lastly, one of the steps that we're going to do in this tutorial is we're going to create an animation, and the animation that it creates looks like this. And so we'll provide you steps for all of the above in this video. Okay, let's go ahead and launch ViaCAD. We're going to use ViaCAD 14. We're going to use build 1639. You're going to have to use 1639 to do this tutorial. These steps are also applicable to not only to ViaCAD but to TurboCAD Mac and SharkCAD. Okay, let's go ahead and set up the user interface for this training tutorial by going over to the tools and selecting the Concept Explorer. I'm going to use the Concept Explorer to turn on and off some cameras. I'm also going to go into the title bar and right click and have it collapse to the top. This allows it to use less of my drawing area with a large dialog box. Next, we'll go over to the tools and we're going to turn on our photo render settings palette. And this has our settings. It has display last image, render to file, render to just render the existing viewport, render a camera, and we're going to use this several times to select a camera and then create a camera. Alright, now we're going to call in our glass on platter start. And let's render this up using all the default settings. We're basically, this is using the pen colors that have been assigned to the model without any materials, textures, or lighting set up. So we'll put it in a view orientation and then just click render camera. Alright, now what we're going to do is we're going to pull out our render settings, and the render settings dialog box actually does more than just your default settings. It also provides a user interface to set up your materials and your textures, your HDRI, and your background. Let's begin by setting the material associated with these three glasses on the table. I'm going to select them, and then I'm going to go to materials, and in this case the glass. We're going to select the glass shader, and we're going to use all the default values where it is using a white clear texture, and hit apply. Alright, next we're going to switch views, and I'm going to change the material of this platter. The platter has some sharp edges on it, so I'm going to select it and go to change resolution, and let's make it super fine, and you can see that it gets much smoother. And now I'm going to go ahead and apply a material. In this case, I'm going to apply a metal, and we'll use palladium. And again, hit apply. Okay, and then one more setting. We're going to use a wood texture on the table. I'm going to select my table, go to the textures, and from the folders I'm going to pick wood, and I'm going to scroll to pick a wood. And I like this one. This is the wood 16.ptx. I'm going to select it and just hit apply. Okay, now I'm going to change my setting to 10 here so I get faster updates, and I'll just hit update the screen. And so now we can see we have our metal on the platter, our glasses, and our texture on the table set up. Next, what we're going to do is add a HDRI. So the HDRI is going to provide us a 360-degree lighting environment, as well as pixels, definitions outside of the materials and objects that we're using. And by default, we're using the default HDRI, and I'm going to pick Studio 0016.exr, and I'll apply that. And I'm going to turn off my background. I do not want this to be my background pixels. I'm going to turn that off and hit apply. And now let's hit render. And we can see the lighting effects associated with the HDRI. Now, because I'm using orthographic projection, we're not going to see the HDRI background pixels. And so what we're going to do is we're going to activate a camera. And I have a camera already made called window camera that I'm going to turn on using my layer manager. And the sharp cone point is where the eye point is, and it's looking at a reference point. And now I'm going to go to the render camera. I'll select my camera and tell it to render. And now you can see the background pixels are filled up with my HDRI image. Now because your HDRI is actually applied to a 360-degree sphere, I always like to have a very high definition HDRI. In this case I'm using an 8K, that's 8K by 8K image map for the background. Alright, and then one more thing. You can see in this image there's pixelization going on. These pixels are white. These are called fireflies, and this is related to the type of rendering that we're using, a PBR rendering technique that samples based on changes in the image. And those areas that are not changing are going to be white. So what we're going to do, we're going to turn on a post effect, and we're going to use a denoiser, and we're going to hit apply. And let's go ahead and do the same thing again and watch the difference. Now the denoiser, it uses some machine learning techniques that fill in the pixels based on neighboring pixels. It does a really good job, and as it continues to render, it will update those approximate pixels with the actual pixel color. Okay, let's do one more thing. Let's show a different camera in operation. So right now our camera is pointing out through a window. I'm going to go over to my layer manager, and I'm going to turn on a camera that points to the wall, and I'm going to turn off my other camera, and you can see this is now a camera going from left to right in this view. And we'll pick our camera and tell it to render this perspective. And this time you can see with this eye point reference point, we're now looking in the same HDRI, but this reference is going to look into the wall. Okay, now let me mention a really nice tool, the render to file tool. The render to file tool allows you to pick multiple cameras or just render the existing view orientation. Alright, the render to file tool allows you to render the existing view orientation to a file, or you can select one or more cameras, and then when you do your render to file, it'll say, hey, we're rendering cameras, just to give you a heads up, and then you specify your width and height. Now, I'm not going to do that right now. I'm going to actually just show you some examples of files I did earlier. So here's an example where it rendered the wall, and then here's an example where it rendered to the window. Okay, now I'd like to show you one more thing, and that is the ability to do animations. And I'm going to go back to the Concept Explorer, and this time I'm going to turn off the wall camera, and I'm going to turn on an animation path. And my animation path is simply a circle that goes around the model with a point at the center of it, where the circle defines the eye point as a function of time, and then the point is an eye point. The point is where the eye point is looking at, called the reference point. And so to do this, we're going to go to the Tools, Animation, and we're going to pick the Flyby tool, and we will select the circle as the path, and we're going to pick this point as the reference point. Now you can specify different height width relationships, and you can also then specify your field of view. I'm going to specify 40 degrees for my field of view, and for my frames I'm going to pick 240. Now this is going to use your render halt settings. So let's say I set it at 60 seconds and I want a 4-second video. That would be 240 frames at 60 seconds. It could be probably 5 hours to generate this. So this is something you may typically want to do before you go to bed or at the end of the day. Now let's go ahead and show an example of a movie that's been rendered with about 5 hours of render time, and you can see how that 360 HDRI is working. Let's have it just play, and you can see the example of an animation. Okay, that's all I have to show you regarding this tutorial. I hope it helps you out with your photo rendering projects. Thank you very much.
Shear tool.
The Shear tool can be used to apply a shear transformation to curves, surfaces, and solids. This allows for the distortion of objects along a specified axis, which can be useful in various modeling and design scenarios. Let's go over the Shear tool. The Shear tool is accessed from the Advanced Transformation tool palette, and it's the last tool icon. Once you select it, select the plane that you wish to do the operation in. I'm in the top view, and I'm going to choose the XY plane. Next, choose the shear angle. The default is 30 degrees. Then select the object that you want to shear and the shear origin. Likewise, you can use a surface. We'll do the same operation. And you can use a solid.
Split at discontinuity.
Hi everybody, in this video demonstration we show how to use the new Split at Discontinuity tool introduced in version 15. So a discontinuity in your curve can cause downstream modeling operation failures, such as Boolean operations, blends, shells, and chamfers. So let's first look at how you can identify that a curve has this type of an issue. I'm going to select my curve and I'm going to go to the Verify, Check Object. And here you can see that, hey, it's noticing this curve's not G1 or C1 compatible. Now, you can get this type of issue to happen when you convert certain text fonts to glyph outlines, where typically a font designer will use Bezier curves that have the ability to have a tangent to the right side of the point that's different than the tangency to the left side of the point. Now, let's show how this can show itself in a modeling operation. I'm going to select everything and I'm going to specify a vector, and let's have it go 2 inches, and then let's grab this last one and we're going to also have him go up 2 inches. Alright, now let's do a Boolean operation, and I'm just going to do a trim, which is a Boolean operation, and let's increase our resolution. And we're going to slide this up, and our goal is to split the solid with that curve. So I'll go to my split tool, trim solid tool, and I'm going to pick the curve, and then you're going to see it fails. This is a common failure message for something with a discontinuous surface or body, where it will say model parameter error. Alright, let's fix the problem. I'm going to get rid of my extruded parts, and I'm going to go back to my curves, and we're going to go to the Modify, Split at Discontinuities. Then we'll select all of these and have it calculate. Now, something that I like to do after using a tool that converts one curve into many curves is the Power Pack Assorted Colors. So this will show each curve in a separate color, so I can see, oh, it took this one curve and made 6, 7, 8 curves out of it. Okay, now let's take our new curves and extrude it up. Let's do 2 inches again, and let's get this last one, go 2 inches. We'll go back to our trim solid tool. We'll pick our curve and pick our solid. Let's flip it. Do it again for the other one. Flip it. And one more thing, let's go ahead and zoom up on this C that's been trimmed and let's put a blend on it. And we'll do a face blend. And then this helps show us too that in order to do that, that has to be a continuous surface underneath it. All right, one more thing I wanted to show you was in version 15, we have our AI assistant can help identify some of these problems as well. And let me go ahead and demonstrate that. I'm going to pick my C, and then I'm going to ask it to examine my selected object for any issues. List each issue in a table with suggestions how to fix. And let's tell it to send that off. Okay, so it's returned back, and it's done a little bit of an analysis on my curve, and it says that the curve has continuity issues, and it also suggests that we use the split at discontinuity tool to fix. Thanks for watching.
Symbol Manager Previews.
Hi everybody. In this new feature presentation for PunchCAD 15, we're looking at a couple small feature improvements related to the Symbol Manager. With version 15, we now can right-click inside the top of the Symbol Manager and get a list of options for displaying our symbols in the lower preview area. For example, you can now increase the size of the symbol to a large preview, and this really helps you get a better idea of the smaller details in some of these symbols. Or let's go to a medium size preview, and then back to the version 14 small previews. Something else that we've done that helps us view large amounts of data that are similar as we do in these nuts is the ability to now display the name right underneath the preview. And this helps us get an easier idea exactly what the symbol we may be dragging and dropping into our design. Thank you.
Text to surface.
The Change Object Type tool now supports an option to convert text to a single surface with multiple faces. Previously, there was just an option to convert text to polygons. And let's demonstrate the difference between the two. First, let's select our text, go to Change Object Type, and select polygons. Here you can see each character is a separate polygon. Now, let's use our new method. Let's select our text, go to Edit, Change Object Type, and this time we'll pick Surfaces. Click OK, and Confirm. And now we can see we have a single surface that consists of multiple faces. Now what this is good for is you can now go to something like the Extrude tool, and it'll extrude everything all as one object.
Tool Help.
Tool Help, accessed by the question mark in the prompt region, was updated to display content in the Copilot tool palette. To access Tool Help, select a tool and then press the question mark. Tool Help includes text, images, and in some cases, video links.
User interface of Copilot.
In this video, we introduced the user interface of Copilot. Copilot is accessed from the TurboCAD Explorer tabbed interface. It's the last tab to the right of Entities, Layers, Symbols, and finally Copilot. Copilot provides access to information that may be of mixed content. This includes text, images, and videos. Information may be coming from our tool help. Pressing on any tool will display the associated help in the Copilot window. It could be info links. For example, selecting the drop-down provides us access to information such as what's new, what's getting started, frequently asked questions, and it could also provide access to our online user guide. And then lastly, Copilot provides an interface to ask questions and get answers from our AI assistant. All right, the Copilot user interface consists of two drop-down menus in the upper right-hand corner. The first drop-down provides access to existing content, especially useful to new users, such as what's new, getting started, and frequently asked questions. The second drop-down provides access to curated questions for the AI version of Copilot. Questions are categorized into help. This is talking with our user guides and our other documentation related to the product. The next set is related to talking to the CAD data, the file that's loaded. You can ask it mathematical and other properties associated with your CAD data, and you will find some example questions to how to do that. And then the third category is the general knowledge base, where here you talk to an AI independent of our application. And then lastly, the ability to convert text to images, which is useful for support of our photo rendering textures and backgrounds. At the bottom of Copilot, you'll find some additional controls that include a back button. This will just retrieve the last AI response that you got. Save, which is very useful for taking whatever is in the Copilot window and it saves it out to an HTML file. This is great for if you have some interesting content that you've created from your CAD data and you want to bring it into Word to further spice it up. Clear, it cleans out whatever's in the response window. And then last, apply. This will take the question that you have entered and send it off to the AI where you can get a response. Lastly, if you have any further questions about Copilot, click on the Copilot Frequently Asked Question link, and this will tell you all about Copilot and provide more details on how to use it.
Verify clearance.
The Verify Clearance tool examines two selected parts to determine if they overlap or provide a minimum distance between the parts. To use the Verify Clearance, select two solid parts and select the Verify Clearance item. This will return the distance of the clearance and also a location of the clearance. And in addition, a line is created between the two minimum distance points. To see it, let's hide our handle and just look at the screw and the line that was created. We'll zoom up and you can see this line is a point on each of the faces between the parts. Another use of the Verify Clearance tool is to determine if a part is overlapping another part or it shares the same space. Let's go ahead and move our part down and now do Verify Clearance, and this time we see that it finds an interference and it shows us the volume of interference.
Thanks for watching.